Gravity may not be a fundamental force of nature. Instead, it could be something that arises from the way matter recursively folds and binds itself into denser and denser forms. When we look closely at the structure of mass, we find that it is already a product of recursion. Gluons, the carriers of the strong force, can latch onto each other in looping, self-interacting spirals. As they bind together, these loops slow down below the speed of light and trap energy inside particles like protons and neutrons. Mass, then, is stabilized density created by that recursive bundling. It doesn't exist as a thing on its own. It is the result of energy folding back into itself again and again. This pattern continues upward across every scale of existence. Atoms are bundles of gluon bundles. Molecules are the next bundles up. Stars, planets, and galaxies are larger and larger clusters of matter holding together through the same recursive process. With each jump in scale, the density becomes more coherent, more organized, and more resistant to being disturbed. What we perceive as weight, what we call gravity, is simply the large-scale pull of recursion accumulating across all the matter in the universe. Einstein's theory of general relativity captures this beautifully, even if it doesn't describe the inner mechanism. Dense structures, deep recursion wells, bend the space and time around them. The more recursively layered something is, the more strongly it shapes the path of everything nearby. In regions of high recursion, time slows down because that density resists the external flow of change. Gravity is not pushing or pulling, it is geometry responding to recursion depth. This explains why gravity has always resisted unification with the other forces. The strong, weak, and electromagnetic interactions are all true gauge forces. They operate through particle exchange and field interactions. Gravity doesn't behave like that. It isn't a particle-mediated force at all. It is the feedback effect of matter becoming ever more recursively dense. It lives in a different category. If this is true, then several consequences follow. Gravity may not only depend on how much energy there is, but on how coherently that energy is organized. Systems like superconductors or Bose-Einstein condensates, where matter becomes highly ordered, might show slight deviations in gravitational behavior. Information density, the amount of structure in a region, could change curvature even when mass stays the same. And some of what we currently attribute to dark matter might simply be the gravitational imprint of unrecognized recursive